Hello, welcome to this Wicked Engine devlog. I will demonstrate what happened in Wicked Engine in the last few months when I haven't made any videos with voice. So the first thing is kind of this little scene, which is called the Snowstorm. I provided this for the Patreon supporters, so you can download that from the Patreon if you are one. This little scene demonstrates how to put many objects like trees in the scene, and they will be rendered with instancing. It shows this snowstorm effect, which is achieved with the two emitter particle systems and some grass particles. Overall, the scene is really simple, just a few white snowball spheres, some trees, the grass, and this particle system effect. Oh, and it also has this predefined camera somewhere. Here it is. So if you load up this scene, that camera will be immediately in this position. And it has also some preset depth of field effect. Okay, so the next thing I will show is that the HDR display support is now implemented. It was implemented last year. If you open the renderer window, then the new option regarding this is called the swap chain format, which is 4 options. If you have a HDR screen, if you have an SDR only screen, then you will have only the top 2 options, which is SDR 8-bit, SDR 10-bit. If you have HDR screen, it will have the HDR 10-bit and HDR 16-bit options as well. So the 8-bit and 10-bit says how many bits per color channel there are. So the SDR 8-bit swap chain format says that it's 8 bits per color channel. So there are four color channels, that's 32 bits per pixel. The SDR 10-bit is 10 bits for RGB and then 2 bits for alpha. So overall it's also 32 bits per pixel texture format. The HDR 10-bit is like the SDR 10-bit, is using the same texture format but a different color space. The SDR color space is the sRGB color space, which is also indicated on the top left corner below the Wicked Engine kind of watermark and resolution display. And that's sRGB when you select an SDR format. If you select a HDR format, such as the 10-bit, and the video recording software unfortunately doesn't display this correctly. It displays it kind of washed out. But then you will see that the color space now is ST2084, whatever that means, and then it's an HDR10 format. It's also 32 bits per pixel, and the heavier alternative is the HDR 16-bit, which uses a linear color space because it's a linear floating point format. And this is 64 bits per channel. Or no, 64 bits per pixel texture format. And yeah, this is displayed also incorrectly by the video recording software. I'll just switch back to SDR 8-bit now. And you won't notice any difference probably between the SDR 10-bit and the SDR 8-bit, SDR 8-bit and the SDR 10-bit. But their difference is that one of them has an 8-bit alpha channel, which could be useful for display compositing to the desktop, which is currently not supported by the engine, so I recommend to use the SDR 10-bit format, which has a bit more precision in retaining colors, so there could be a minuscule amount of more image improvement regarding color banding and such. The next update is kind of the DDGI, which I'll show in the sponsor scene. I'll delete this scene. And also I disable depth of field for now, just to not confuse me. I'll open the sponsor scene. And the diffuse global illumination, that DDGI stands for dynamic diffuse global illumination. It's a ray tracing effect, but a probe based one. So it's not a per pixel ray tracing, but per probe ray tracing. For now, I'll disable diffuse lighting because it's a diffuse only effect. And I will disable albedo maps. As you can see, this is the sponsor scene without much indirect diffuse illumination. Every indirect diffuse, such as the thing you see here, is coming from the sky colors and some ambient term, which is not at all accurate. If I enable the DDGI here in the renderer window, then the dynamic global illumination will kick in. I will also disable the grid for now. And you can see that it's kind of affecting immediately. And it is completely dynamic, so if I rotate this sunlight, for example, just to demonstrate, it will be updated, but with a bit of a time lag, it's worth to be said. You can also debug this effect by enabling this debug checkbox. It will show you the probe grid, which is a very high resolution probe grid for this scene, and for that reason it's also a bit slow. You can change the grid resolution if you find the header file for the DDGI and modify some parameters and rebuild the engine. For now, these parameters are not exposed as real-time modifiable parameters. The one thing it's important to mention with these probes that they are also updated dynamically, their positions. At all times, they will try to keep a distance from all surfaces to minimize the potential light leaks. These also support dynamic objects and particle systems as well. For example, this curtain is also dynamic, but let me, for example, remove this curtain, and then you will see that the lighting updates and kind of starts leaking into that corridor. If I start deleting curtains, then yeah, the light will immediately reach to more places. So again, this is the scene without the DDGI. This is it with DDGI. There is also another dynamic diffuse global illumination technique, but it's not a probe based, but a surface based, which is the surface GI. And this is kind of the same thing, but achieved differently, and it has other drawbacks and other properties. It has some other debugging features, such as you can debug surface normals, surface colors of the indirect lighting, the surface points. So essentially what circles are is each circle is kind of like a DDGI probe placed exactly on top of the surface, and it has the indirect illumination not in all directions, but only within the hemisphere of that surface point. This is each circle choosing a random color for itself. The next large update is the terrain generator for the editor. Currently this is only an editor feature, and you can access it with this button on the bottom right corner. Just click on it and your terrain will be generated immediately. As you can see, if you move the camera, the terrain will be continuously generated around the camera, and the terrain will be removed if the terrain chunks get too far. Well, what is a terrain chunk? A terrain chunk is is a rectangle like this, which is basically the terrain surface, and any object placed on the terrain surface at that little region. The terrain is divided up to lots of these chunks, which are 64 by 64 vertex size meshes, essentially. On the closest by chunks, also some grass particles will be generated, which are kind of fun as well. You can interact with these in the editor by just clicking on the terrain where there is grass, and it will put down this force field, and the force field can push away any particles, such as these grass particles or any emitter particles as well, if you would have those. For the grass is also interesting to enable some effects like some ambient occlusion, which will cause the grass to be more realistic in the shadows with this light occlusion effect. Ray traced shadows can also be enabled, which is another very nice looking feature for the grass. Unfortunately, it's also very slow. Maybe in the future, the ray traced shadows for the grass will be really well usable. But for now, I'll just bring back the original shadow maps. As you can see, not only terrain mesh chunks are generated, but also different objects on top of the terrain. There are 3 objects included right now into the editor by default. The tree object, the rock object, and the bush object. And these are just placed randomly on the terrain based on different criteria. For example, trees are more broadly spread out, and as opposed to rocks, which are placed kind of closer by to each other and not spread out evenly along the terrain, and the bushes are kind of the same. You can fire up the editor's source code and see how these object properties are specified. And you can also include your own objects and play around with generating a different terrain than the editor defaults. There are also lots of parameters to the terrain, which I will not go through now, each of them. Basically, there are some features that you can enable, such as center to the camera. If you disable this, then the terrain chunks will not be generated anymore around the camera, but the camera is kind of stuck in that position where you deselected that, and it will not, things will not be generated anymore, but the world will be more static. And you can disable removal, so if you move further, then things will be generated, but things will be not deleted, essentially. And that will be, of course, a major hit on performance after a while. Let's re-enable that, and then that will clean things up. You might have noticed that there are some interesting looking cloud shadows on the ground, which are not at all in any way related to the actual clouds in the sky, which are the volumetric clouds by default. These are just simple shader-based noise affecting the lighting, the directional lighting a bit, which will just make it look more interesting. Maybe you also noticed that there is some object popping, which is the new load system. Load stands for like level of detail, and that can be visualized best by going to the wireframe mode in the renderer window. And you will see that chunks that are farther from the camera will receive a different level of detail. They will use less triangles, essentially. The load system is seamlessly integrated with the rest of the engine. This will not require any code modifications for existing content. They use the or the existing mesh subset feature, which is just a subset, a range of the index buffer specified. So cursor load levels will be just using less indices of the mesh basically, but the same vertices. The terrain chunks use a custom load implementation because the terrain is is a specific requirement of chunks that have different LOD levels and are nearby. They must have some connection vertices so that there will be no gaps between them. So basically this required a custom load LOD implementation. And as you can see, the borders of the chunk meshes have this kind of constant, very high resolution vertex apron or border, which exactly matches the highest resolution level of detail. If I remain in the wireframe mode and check out a rock or a tree, for example, you will also see some level of detail behavior, and that is a different LOD implementation. It uses the same LOD system to select the LOD level by the rendering engine, but the LODs are generated actually by a different algorithm because they don't need to match. These meshes don't need to connect with the nearby meshes. This uses the Mesh Optimizer library, which is a free C++ library. I downloaded it from GitHub. It's a very good library. It's mesh optimization and load generation and who knows what else it can do. The editor basically already had this library, so it was natural to try it for generating loads as well. So let's see. If I go close to a tree that's kind of separated from others, you can see the load transitions like this. Let's go back to the non-wireframe mode. And I will also show you that you can select a tree and open the mesh window. There is a new load generator. With this button, new LODs will be generated with these parameters. There is a load count, how many levels of detail it will have, what's the expected load quality reduction between successive load levels, and what's the allowed load error between the levels. And then the sloppy load, it uses a different kind of load algorithm, which is faster but less accurate. For the trees, it is kind of very visible. If you increase the load error, the default load generator will generate very bad loads with the tree coronas, the tree leaves completely disappearing from lower detail loads. You can of course modify this by decreasing the load error, or if you enable the sloppy load, it will also generate a different kind of LOD, and you will just have to experiment with these settings on your own. The same is true for the rocks and the bushes as well. They will probably require slightly different LOD settings. So apart from this, the terrain also has some neat presets. I'll just go back to the original camera position for now. Reset camera. We'll just regen the terrain around the camera again. And I will select the islands preset. It will generate this kind of island terrain, which you can see is a small island. This island preset also has the ocean enabled, and now it's worth to mention some ocean updates. First, the ocean rendering was optimized. For example, a small optimization was rewrite it with the index buffer index buffered rendering. So that's rendering the surface of the ocean is slightly faster. Then there is new occlusion culling feature for the ocean. So if the ocean is not visible for any camera, for example, a tree completely occludes the ocean like this, or you just look down to the ground, the ocean itself will be not rendered at all, the ocean surface. But apart from that, the simulation of the ocean will also be skipped, and rendering the planar reflections for the ocean will also be skipped. So it can result in huge performance savings. The planar reflections for the ocean, I mean, is that rendering the scene a second time with a different camera. So that's a kind of a heavyweight effect. Even if those those planar reflections use a reduced resolution, they will still require all the draw calls that the original scene rendering needs. And some other ocean updates is the addition of the underwater effect. If the camera goes partly or fully underwater, then the underwater effect will kick in. As you can see, it's an added underwater fog and some screen wobbling effect, which of course is not physically based or anything. It just looks cool. You can disable this if you want. And some neat caustic pattern effects, which are also just a shader trick. They are not related physically with the actual waves of the ocean surface, but they just look good. They are kind of similar to these cloud shadows moving across the terrain surface. As you can see, this kind of island preset is kind of small, but don't let that confuse you. It's still an infinite terrain. So if you start moving to the opposite direction with the camera, once after a while you will find another island. So this terrain preset just generates these kind of small separate islands in an infinite ocean. I don't have to go back to the original camera position, but for now let's do that. Just because I kind of set up these terrain presets to always look good in the default camera. So now I select the mountain preset. This preset is a mountainy terrain with some flat land, flat foresty, grassy land surrounded with these big mountains. If you go up to the mountains, there will be no trees or grass anymore. It will blend instead to the rock, slopey, rocky texture, and there might be also some snow on the very top if there will be a very large mountain. A lot of these parameters can be tweaked. I won't go into details into each of them in this video. Let's just check out another preset. The last one is the Arctic preset. This is kind of a flat-ish land with some slopes and whatnot, but it's completely snowy. That's specified with the high altitude region. Okay, so this might be a bit confusing by the high altitude region. The fact that it's set to 0 says that it's used fully across all the vertices, this material, because it's computed as something on the power of 0. That will be always 1, so it will just take over all the other terrain material regions. Let's go back to the hills, to the default terrain. And one other feature I would just like to highlight is that this terrain that you generate with this terrain generator is the terrain generator is just generating a regular mesh with multiple objects and meshes. So if you want, you can just save the terrain out to a model file that will not be dependent anymore on the terrain generator settings. That also means that it will not be generated anymore dynamically around the camera. But this is something you can consider. If you want to delete the terrain, then one way to do it is just to delete it like any regular object, or just hit the clear world button, which will delete everything from the scene, and in this case the terrain window will disappear. If you want to generate it again, you will just hit it again and generate it again. So this terrain is kind of good looking, I think, from this kind of perspective, close to the ground. But if you move upwards, then the terrain borders, or it will be obvious how far the terrain was generated, which is not something that's very nice. This is because the current terrain generation algorithm is kind of a simplistic one. It generates these terrain chunks which are uniformly sized. And this was a kind of simple to implement, and for now I kept it this way. In the future, I think that it would be better if farther away terrain chunks would be, maybe they kept the same vertex count, but they would be much larger, increasingly larger in fact, and that way they could just cover more ground. And of course the trees, the amount of the trees could also be reduced in the distance, like dynamically, or they could use the impostor system, which is actually not working really well for this right now. That will be also, I think, to improve in the future. Because this is the editor, you can also do different kind of things with this terrain or the objects on the terrain. For example, the regular things like selecting an object, grabbing it, or pressing Ctrl D to duplicate it. Or you can also press Ctrl C to put it to the clipboard. Of course, you can press Ctrl V to duplicate it that way. But once the object is on the clipboard, as I showed in an earlier video, you can also hold the Ctrl Shift key, the Ctrl and the Shift keys together, and then if you click somewhere, then you will place one more instance of that object. This way many objects can be dynamically placed on the terrain. But of course they can also be placed on top of each other if you want, so like this. Probably it's not very good for the trees. You can do the same for rocks, press Ctrl C, and then you can put the instances with the Ctrl plus Shift and then clicking like this. All the objects that you place with this instance placement functionality will place the same mesh with different instances to the scene. So if appropriate, they will be rendered with the instance rendering commands, which means that multiple objects will be rendered with the same draw call. Of course, some things that can break the draw calls are LOD transitions, level of details, because different LOD levels will have to use different index counts for drawing, and those require different separate draw commands. In those cases, the draw calls, there will be more draw calls, but the LOD system will potentially reduce the performance requirements. Okay, so this is it for today's video. I don't know when I will make another one, another video which I will voice, but stay tuned for more. Maybe I just keep posting smaller videos, I don't know yet. We'll see in the next video. Bye.